Our industry faces a lot of challenges. With an increase in depth and complexity of the wells, we may run into problems with well integrity. Cement is one of the crucial elements regarding well integrity, and in order to avoid fluid communication and loss of integrity, we need to take a look at two different parameters: sealing capabilities as well as the mechanical properties. So for the sealing capabilities, there are already measurements in place which are able to ensure it. However, when it comes to the mechanical properties, we may run into problems and we have to rely on laboratory experiments. For our project, we have a two-component experimental setup. On the one hand, we have a triaxial cell where we insert samples, then we equip them with strain gauges in order to record the deformation. And on the other hand, we have involved ultrasonic measurement component with piezoelectric sensors. When we conduct an experiment, we put the slurry into the UCA and cure it there under specific conditions. We then try to replicate those conditions in the high pressure, high temperature curing chamber. The cured sample is then inserted into our experimental setup, where a triaxial test is conducted with simultaneous ultrasonic measurements. This project is split into two different objectives. The main objective, which is the correlation of the ultrasonic measurements to get the mechanical properties in order to understand the interplay between those two components. As a secondary objective, we have the analysis of certain mechanical points and their effect on the ultrasonic measurement. For example, those points are the maximum stress, failure, and the boundary between the elastic and plastic deformation. Knowledge about this interaction between these two measurements allows us to apply it for CCS, geothermal, as well as oil and gas wells.